But it is your sorry luck to have to finish the nuclear fuel cycle. We can't leave the nuclear fuel cycle unfinished. It's hanging in the air here, folks. Come on. It's not fair to the nuclear fuel cycle to leave it incomplete. I feel so incomplete. I feel like I could have been a real cycle. The nuclear fuel cycle is really not exactly a cycle, as you're going to see. A cycle implies that it goes back to the beginning, and putting it in the ground, which, well, there's some irony to that notion. But anyway, without getting ironic, I will proceed with the nuclear fuel cycle. Where, when we last left our hero uranium, it had gone through the gaseous diffusion process, and it had been made into pellets in the fuel fabrication process. And at that point, so it goes from U308. By the way, these are, you should know these, U308 to UF6. And then finally, in fuel fabrication, the fuel pellet is UO2 embedded in a ceramic matrix. Not like the matrix. Matrix means anything that something is surrounded and supported within. Okay, and then, of course, it goes in the fuel plant. There we go. Okay, so then they go through what the book, I don't know, with a straight face somehow calls fuel burning. What's wrong with that statement?
It's cool.
What's that?
Those are the cooling towers?
No, but I mean, what's wrong with the statement fuel burning as far as nuclear fuel? I can't hear it. Well, it doesn't burn. It's not burning, right? That's when the fuel is burning. That's bad. Like if some nuclear fuel is burning, that's not good. I think something's gone very wrong because yeah, it doesn't burn. It fissions. They shoot neutrons at it. It fissions and water boils and all that. Which of these three structures is the place where the nuclear fuel is actually burned? The dome. Yeah, right. Remember, it isn't these towers. Those are the cooling towers, as we discussed yesterday. That's where the fission reaction happens in there. Okay, so fuel burning, and then, well, this is the point where the cycle becomes a little less of a cycle than is implied in the name nuclear fuel cycle, because there's two things that could happen here. You end up with waste, first of all. Where's the purple? Purple would be good for it. I need purple. What's that? Yeah, that's like a wet erase though. I'll just go with I got purple dry erase. I got purple. I ordered an extra box of purple because it's my special color. So now what you have left is what's called waste. About every 18 months, they take about a third of the fuel out of a nuclear power plant. So I guess that means that a fuel pellet has a life of about, what would that be, 48 months? And what happens is there's actually only 1% of the fissionable material is used. But what happens is you get a buildup of fission products around the outside, and I guess maybe other chemical processes, but you get essentially a crust around the outside that keeps the neutrons at bay. So ultimately the neutrons fail at getting in and fissioning the atom. Nothing useful happens anymore, and so they take the pellets out even though they're only 1% used technically. And so there's two different things that can happen. In some countries, they do what's called reprocessing, where they take the fuel pellet, they drop it into acid. So here's your spent fuel pellet here, covered with its coating. They put it into acid. And then it dissolves. A lot of this other stuff goes to the bottom. It's a very involved process. I'm oversimplifying, but the point is, what they then can do is they can remove they can have new uranium. And the other thing that you get from this process is plutonium-239, which is a product of these pellets getting hit with neutrons. One of the things that can happen besides splitting is just to change into, it's called transmutation, into plutonium-239. And so you can remove the plutonium-239. This is used in weapons. The new uranium can go back into the fuel cycle right here, be fabricated back. Actually, no, it needs to be enriched. But anyway, so that's one thing that can happen. That's your this is your reprocessing option. We don't do this. We don't do this in the United States. We used to do this. There's a plant upstate New York somewhere that was closed after 3 Mile Island. It looked like the nuclear industry was dying. They weren't going to build any new plants, and so therefore there was going to be no need for reprocessing. And the reprocessing plant in upstate New York is also, it's had a checkered history as far as safety, and apparently there's an enormous contamination plume underneath it. But so it has a lot of problems too. All of these things become, instead of high-level nuclear processes like in a plant that are very safety-oriented, these are all industrial processes that people make mistakes. You know, it's just guys with jobs as opposed to highly trained engineers with multiple inspections per month, and, you know, like you have in a nuclear power plant. So mistakes apparently get made. But okay, I don't want to editorialize. So the other thing that can happen is just waste deposition, I guess you would call it. Long-term storage. Waste storage. We're going to have a whole lesson devoted to waste storage and all those options, and so I won't talk about it right now. But just realize that the nuclear waste issue is one of the big issues that we still have to talk about in our coverage of this topic. Okay, so that's pretty much it. You can see it's almost a cycle. I mean, if you were to reprocess it, then in theory you could call it a cycle, because then you could go over to here, and it would keep going through. As it is, that doesn't really happen, and this is the option. And right now, there is no central waste storage facility. We'll talk about that too. But so most of the waste is stored on site at plants. We'll also talk about the multiple different kinds of waste. But anyway, so that's the nuclear fuel cycle for you. Okay. Any questions? You can read about this in section 10.6 of your book, pages 384 through 87. Thank you very much. I'm Mr. Arwach.